What form is this? This is of the form 1 over a squared plus u squared, where a squared is 4, u squared is 3x squared. That's right. So let's do that. So this is of the arctan form. Is that right? 1 over a squared plus u squared, integral 1 over a squared plus u squared du is 1 over a arctan u over a. So we have a squared equal to 4, u squared equal to 3x squared, and we will write it like this: integral 1 over 2 squared plus, look at that, square root 3x all squared. Now what is square root 3 all squared? Square root 3 squared is 3 times x squared. So when u squared is 3x squared, u is square root 3x. Well, so a equal to 2 and our u equal to square root 3x. Well, if that is the case, what is our dx then? Our dx, when this becomes u, our dx need to be replaced. So our du equal to square root 3 dx. So our dx will become du divided by square root of 3. Okay, so this integral now is integral 1 over 2 squared plus square root 3x is now u squared times dx now became 1 over square root 3 du. Well, this is standard form, and that will be 1 over square root 3, that comes out integral 1 over 2 squared plus u squared du. What is this integral? It will be 1 over a arctan u over a plus c with 1 over square root 3 outside. So that will be 1 over 2 square root 3. How did it become 1 over 2 square root 3? It will be, remember, this will be 1 over 3 times, this integral will be 1 over a. 1 over a is 1 over 2. That's where the 1 over 2 comes from. So this 1 over 3 times 1 over 2 makes it 1 over 2 square root 3 arctan u over a, u over 2 plus c. And that will be replaced by your u. That will be square root 3 over 6 arctan square root 3 over 2x plus c. Alright, so the most important thing here is to see the basic form, a squared plus u squared form, and then make the appropriate substitution. Another one, evaluate the integral. Integral 1 over square root of 2 minus 2x minus x squared dx. Now, this is an excellent candidate to make it of the form square root a squared minus u squared or u squared minus a squared, one of those forms. How? Well, what we can do is we can do some manipulation in the quantity there. This integral can be written in the arc sine form, a squared minus u squared form, by completing the square inside the radical sign. Well, I'm sure you know the skill of completing square. Let's do that. So, what is this equal to? Inside the radical, we're going to complete square. And look at the way I'm going to do that. First, I factored out a negative sign from there, and I wrote under square root 2 minus, after factoring the negative sign, I wrote 2x, x squared plus 2x, x squared plus 2x with the negative sign outside. If you distribute the negative sign, you get that. Now, tell me, what do you add to x squared plus 2x to make it a perfect square? You got the first term, the middle term, and the last term is missing. Remember, for a perfect square, the last term is take half of the coefficient of the middle term and square it. Half of 2 is 1. So add 1 squared to this. But remember, when you add a 1 here, you are actually subtracting a 1 because of that negative. You are subtracting a 1 under the radical there. So when you subtract a 1, to compensate that, you need to add a 1. So look at the way we're going to write it. What will you add to x squared plus 2x to make it a perfect square? Look at the way I have done that. X squared plus 2x plus 1 is a perfect square. That means I have added a 1 inside this bracket. But adding a 1 inside this bracket is the same as subtracting a 1 because everything inside the parenthesis is subtracted. So to compensate for subtracting this 1, I added a 1 outside. So when you distribute this negative sign and simplify, that negative 1 and this plus 1 will go. We haven't really done anything inside. Is that right? Okay, but this 2 added to this 1 will become 3, and this will be x plus 1 raised to the power of 2. This is x plus 1 to the power of 2. Alright, so this will be integral 1 over square root 3 minus x plus 1 squared. Now this is of the form 1 over square root a squared minus u squared, where a is square root of 3, a squared is 3, and u is x plus 1. That's right. So we substitute x plus 1 equal to u. That will give dx equal to du. So x plus 1 becomes u, dx becomes du. Here we have our next form. That will be integral 1 over square root 3 all squared, a squared minus u squared du, and integral 1 over square root a squared minus u squared is arc sine u over a plus c. So this is the arc sine form. That is integral 1 over square root a squared minus u squared is arc sine u over a plus c, where you are a equal to square root of 3 and u equal to x plus 1. So your answer will be arc sine u over a x plus 1 over square root of 3 plus c. And that's a beautiful integration form, and please go back and have a look at it one more time. Okay, another one. Solve the differential equation dr by dt equal to 1 plus e to the power of t all to the power of 2 over e to the power of t. We have done questions like this before. When you want to solve a differential equation, you can see r is the dependent variable and t is the independent variable. Solving the differential equation means solve for r. So the first thing to do is separate the variable. Multiply both sides by dt so that you have dr alone on the left side. Is that right? Yes. So we need to solve for r as a function of t. The first thing to do is multiply both sides by dt, and that gives you dr equal to 1 plus e to the power of t all squared over e to the power of t dt. And in order to get r, we integrate the left hand side and the right hand side. But before that, let's expand the numerator. What is 1 plus e to the power of t all to the power of 2? A plus b all squared is a squared, that is 1 squared, plus 2ab, 2 times 1 times e to the power of t, there you are, plus b squared, e to the power of t raised to the power of 2. Then you raise a power to the power of 2, simply multiply that power. That will be e to the power of 2t. So e to the power of t raised to the power of 2 is e to the power of 2t, all divided by e to the power of t. Well, now you can split this into 3 pieces. This is 1 over e to the power of t plus 2e to the power of t over e to the power of t plus 2e to the power of t over e to the power of t. You see, that will, once you write it like that and simplify it, we can integrate each term. What is 1 over e to the power of t? It is e to the power of negative t. And here, 2e to the power of t over e to the power of t, e to the power of t will cancel. Alright, tell me, what is this? E to the power of 2t divided by e to the power of t. This needs to be read as e to the power of t. This is something like this, x squared over x. It will be x. E to the power of 2t divided by e to the power of t is actually e to the power of t. So that will be e to the power of negative t plus e to the power of t dt. We can now integrate each of these. Alright, so we integrate both sides. Integral dr equal to integral e to the power of negative t plus 2 plus e to the power of t dt. Well, what is integral of dr? Is r. And integral e to the power of negative t is negative e to the power of negative t. Integral 2 dt is 2t. And integral e to the power of t is e to the power of t itself plus c. And that is the form of r we have. And this can be rewritten as negative e to the power of negative t is negative 1 over e to the power of t plus 2t plus e to the power of t plus c. Or take e to the power of t common as the common denominator, then e to the power of t will multiply in the last two terms. That would be negative 1 plus 2t e to the power of t plus e to the power of t times e to the power of t is e to the power of 2t. So we take e to the power of t as common denominator and you get this. And therefore, your solution for the differential equation is r of t, r as a function of t, is, write it like this, e to the power of 2t plus 2t e to the power of t minus 1 all over e to the power of t plus c. And this is the best way to write that answer. Alright, let's move on. Evaluate the definite integral, integral 1 to e 1 minus ln x over x dx. So there is a clue right in there that if you do a substitution, you can do this right away. Why? Because the derivative of ln x is 1 over x dx. You see, so if you can replace 1 minus ln x as u, then its derivative will contain 1 over x dx. And that is the clue that you should see right away. Now think of a substitution that will reduce this to a standard form. It's very simple. 1 minus ln x equal to u. Why? Because the derivative of ln x contains 1 over x. That's right. So we say 1 minus ln x equal to u. The differential of 1 is 0. The differential of, with the negative, differential of ln x is 1 over x dx. Differential of u is du. So 1 over negative 1 over x dx equal to du, and therefore 1 over x dx. See, when this becomes u, you need to replace 1 over x dx. 1 over x dx is negative du. Let's do that. Well, before we do that, we need to replace our limits using this substitution. Alright? Now here, when x equal to 1, let's bring x equal to 1 here. What is ln 1? ln 1 is 0. So when x equal to 1, u equal to 1. So that limit will remain the same. When x equal to e, what is ln of e? ln of E is